Hey guys, welcome back to AlgoYogi. We are doing linked list now. We have already done the first problem. Let's move on to the next problem, which is merge to sorted list. On the on LeetCode. So you are given the heads of two sorted linked lists, list 1 and list 2. We need to merge. These are sorted lists, so merged list should also be sorted. So merge the two lists into one sorted list. The list should be made by splicing together the nodes of first two lists. So basically the red list and the violet list, we merge them together, but not just one after another. It's just like the values needs to be in the sorted, and they're not like strictly increasing, or because these values together, they are not like unique. They have common values, so we have to take care of that as well. Now let's see how we're going to do it. All right, so these two lists, list 1 and list 2, this is L1, let's call it L1, and this is L2. And what they must have done is basically, now we have our pointer L1 here and L2 over here. They must have checked, right? So final list, let's call it F list, which is final list, and don't think anything else. If you think it's something else, then you're a bad person. No, you're not. I'm just kidding. I should have chosen a better word, but I'm just gonna call it F list for now. So that's, let's say it's pointing to nothing right now, maybe just pointing to anything. But now we choose whatever is bigger. They're equal, so we can choose any. So our first node would be 1. Then let's say we chose L1. Then L1, we are incrementing it to 2. Then we compare these two. Then we are comparing these two, and then we see this is what is smaller. So we basically assign this one. And let me change the color because this one is not same as the first one. All right, and then honestly, why am I doing it over here? Because this is already done over here. So this one comes over here. Sorry, they could have chosen anything, but they chose to go against me. I want to choose this one. Doesn't matter, guys, let them do them whatsoever. But then over here, then 2 over here, 3 over here, 4 over here, and 4 over here. So basically we're doing just choosing the smaller of the current element of these two lists and just placing them onto my final list, and that's it. So we're gonna just iterate over both lists, and then simply keep appending it to our final list pointer, and in the end just return the head of the final list pointer. So honestly, only just one edge case, which is, what if they are not of same length? Then what? Let's say if my list one was 1, 2, and 3, and my list 2 was, let's say, 2. That means what? These are not equal length, so we cannot iterate both of them inside like a for loop or like maybe like a while loop. Then we will have some way of processing the equal lengths. Basically, I will have my final list created with the length that's minimum of these, and then once the smaller list gets consumed into my final list, then remaining, whichever list remains, I will just append it to my final list, whatever it is. All right, so let's say in this case, initially it would be 1, and then it would be, let's say, 2 coming from here, and then 2 comes from here, and then finally this is gone, right? Like this is used. Now we don't really have to iterate and compare these values because there wouldn't be any value over here to compare. Then I'll just finally append whatever left in the bigger list, or the list, it doesn't have to be the bigger list, it's just the list that's values are remaining. I should say. All right, then it will be big of n time complexity because of and n being the largest list, or together they could be called, because at the end of the day it could be 2n if both of them have equal number of nodes, but I think n would be better to say. All right, so as I said, we're gonna have f list, and that is currently, let's say it's pointing to 0, doesn't really matter. Then we're gonna have let's say current pointing to my f list, and while list 1 and list 2, I want to compare if which value to use, which value is smaller. If list 1 dot val is lesser than or equal to list 2 dot val, that means my current dot next would be tree node of value list 1, because I'm choosing the smaller value because I need to keep the list sorted. All right, so list 1 dot value. Now since I'm using value from list 1, so I gotta increment it. So list 1 dot next, not list 1 dot next, list 1 would be list 1 dot next. All right, because I'm moving it in the same list to the next pointer. At the same time, my current dot next would be not current dot next, again I'm making the same mistake. My current would be current dot next, which was basically this value, the node that I created. If this is not the case, then else same thing is gonna happen, but only with list 2, because now list 1 must have been bigger value, so list 2 will be a smaller value, and list 2 will increment to the next pointer, and current will just go about being same. And then the last edge case, when they're not of same size, then we're gonna check if there must have been one case either list 1 or list 2 is remaining, and one of them has been consumed into our final list. So if list 1 remains, then cur dot next would be just list. We're not going to do any iteration over here, just whatever remains in the either of the list, just append it. So if list 1 remains, list 1 is appended to the final list, or it's list 2. All right, so not list current dot next would be list 2, and that's it, we're done. And now let's just return. We're not returning current, although we were working with current. We're going to return final list. All right, because we're going to return the head of the list, not the, because current must have reached to the final node, or maybe I would say none at this point. So we return final list, but remember that was 0, so next, because that must have started one of the values of list 1 or list. And that was really stupid of me creating the tree node rather than list node, so forgive me for that. And I think that's coming from basically from tree series. I'm just so used to creating the tree node. But anyway, now I think it should be all good. Let me zoom out, and that's all good. Let me submit it. Expecting 100%, of course, because it's efficient solution. So let's write down the time complexity, which is big of n. N is the total number of nodes, you could say, or yeah, I would say, and or m plus n, nodes being m in list 1 and n being in list 2, and space complexity is also big of n, because at the end of the day we are storing it, you know, in the memory. So I'm just going to write it m plus n, so that, you know, m plus n, and you know what m and n are. They're the number of nodes in list 1 and list 2. All right, let's go back to AlgoYogi, mark this problem solved, and see you guys in the next problem. Until that, bye.